Hey, everybody. So my goal today is just to give you a high-level introduction into why Cromwell exists, actually more so than anything else, depending on what you're trying to do, help you answer the question of like, okay, does it make sense to use Cromwell for your specific needs? And then towards the end, demo quickly what it actually means to use Cromwell. What I won't be able to sufficiently do today is like explain all the ins and outs of Cromwell. I think if this session helps you decide, yes, Cromwell is the thing that I should be using for my research, then I'd be very happy to do like a follow-up and a deep dive into more of the magic around like what can you do using the engine. Yeah. Okay. Cool. I don't have like good, because of the way the Zoom formatting works, I don't have great visibility into the chats. So feel free to just interrupt. I'm very okay with that. Having done this presentation many, many times in my life, it's no big deal. So just speak up and interrupt me whenever. Excellent. Okay. So I think at the highest level, I'm not sure how many people here have used just general pipelining tools before. But if you haven't, then this early set of slides will be important for you. So in general, I think workflows or pipelines, sometimes I use those terms interchangeably. So for me, they kind of mean similar things, but not the exact same thing. Workflows or pipelines are ways to handle a task that you want to automate at scale. So let's say that you're working on a cohort of samples, there's 1,000 of them. And you figure out a way that you want to filter some read level data or filter some variant data and then run some QC step on it and do some kind of annotation. So there's a set of repetitive tasks you're trying to do for each single VCF or each single sample that you have in front of you. Then that's the kind of use case where I feel like Cromwell is especially useful, because what you want to do is chain together. You want to build a logic around those repetitive tasks. Sometimes there's a linear sequence. Sometimes there's a parallelization you want to do. So there's different structures. And then when you put all those tasks together, that's what in the terminology of what we're going to discuss today is, in this context, is a workflow. So a workflow is like an end-to-end process composed of many different steps or tasks. And Cromwell is the engine that executes that entire workflow, and it can scale across many different instances of that workflow, depending on how big your cohort is to begin with. And we could talk about sort of like, what are the benefits of doing all of this, but I think that'll be less interesting. So I'm just going to go ahead and move forward. Okay. So what is WDL? So WDL, WDL, stands for Workflow Definition Language. In the case of Cromwell, WDL or WDL is the actual literal language that the engine can understand. So when you craft your workflow, you have to write it in the WDL language. And we'll talk about what it is. It's not a very complex language. So it's not like a Python type of programming language. This is meant to be it's meant to be sort of a human readable language. And so it's for people who are new to programming, and it requires very little programming knowledge to actually draft your workflow in the WDL language. That's the real reason it exists, because there are a lot of existing pipelining languages that take things like Python that let you write workflows. And it's great if you already know how to write Python, you already know how to write workflows. So WDL is trying to solve that problem. If you're familiar with Nextflow is also a human readable language that is also trying to solve the exact same problem. And I think there must be a slew of other ones that exist, but those are the two that I'm most familiar with. DSub is different. So if you've already used DSub on a platform, the thing you've already learned is that DSub is great for taking a single command, a single task, and running it at wide scale. WDL and Nextflow are different because it's about chaining together multiple tasks in a workflow and then running that workflow at scale. Any questions so far? Okay, great. So I'll just do a high-level overview of what is WDL and what does this human readable language actually look like. Yeah. So in general, I think let's start on the left-hand side. What is a task? So for any given task, there's 4 main components. In the yellow, what you're seeing up here are a list of inputs. So in this case, I have a file type. The caps will indicate that there's a very strongly typed input here. So it's definitely a file, and the variable name for it is just ref, and then a file just called in, and then a string called ID. And so these are the 3 inputs, or the recipe inputs for my task. And then below here in the command section is the literal it's the literal script that's executed. So at any given point, you should be able to take out everything that's in the command box and run it on your own terminal. Yeah. So this is using sort of like a bash interface to run the command. And depending on the kind of tool you're trying to execute from the commands will look wildly different. There's a runtime portion of your task, which thinks about things like where this actual task is going to run, how much disk space will it need, how much CPU and possible memory it might require. Docker is also a key part of it, which may be new to a lot of you, but essentially Docker will containerize what are the software packages and the environment in which your command is run. And then once you run your command, usually there will be some outputs that come out of it, usually file outputs that come out of it. Depending on what kind of calculations you're doing, maybe there are some numbers that come out as outputs. So your output can be different types of information and that you predefine that you want to capture. So those are the basics of a task. And without going too deep, at the end of the day, the workflow strings together different tasks. And we'll talk about what does it mean to actually string together those pieces. So there's 3 different modes of stringing together tasks for a workflow. So you can linearly chain things. So you can say, hey, run step A first, take the outputs of step A, put it into step B as inputs, and then kind of moving forward. What that actually looks like in WDL is shown here in like these black boxes. So if you just want to call one single task, you say, hey, call task name step A. And then when you call the next task, you have to specify, well, the input of it has to come from the output of the previous task. So this is the general syntax you would use in the language. You can also, the multi-in out example is more like saying, sometimes you need to run 2 steps, consolidate their outputs into the next task. So that's the example showing here. Then the scatter gather on the right-hand side is also a very common mode, especially when you're working with genomics data that's been chopped up into tiny little pieces. So the most common use case for your scatter gather is you've taken your entire genomics file, you've broken it down into intervals, and then you run the same task across each of those intervals. And then you've glued together the outputs of all of those back together. So that's where the scatter gather methodology is most commonly used in the context of the type of data we work with. Any questions so far? And all these examples that I'm showing here, I'll explain to you where you could find some of this after the fact as well. Excellent. So far, what I have been doing is just kind of talking through the general types of format, the general type of information you need to know to craft a WDL file, because the WDL file is the language that Cromwell as an engine will understand. So very soon, what we're going to do is transition over into how this actually looks like in the AOU research workbench, because this is talking about it, just what the concepts are, and then we're going to apply those concepts to the research workbench. And I wanted to show a little bit of detail for what the runtime section of a task looks like, because I think some of these concepts can be new and they're a little bit confusing. So if you're used to using the sort of like a compute cluster at a university, you may or may not have ever had to worry about things like, well, how much disk do my tasks and these commands actually use? How much memory is actually required? And Docker could also be completely different. It could be a completely new ballgame for you as well. And so I think there are some built-in defaults that exist. So you don't have to specify disk on day 0 of using this. You don't have to specify memory. You don't have to specify preemptibles. None of that stuff has to be specified, but those are parameters. There are some set defaults that exist, and then you can set those increase or decrease these parameters as you use them more. The parameter you absolutely have to specify are Docker containers. And in case the link is not easily available to someone right now, the support site actually has the All of Us program has published a Docker image in the Google container that exists publicly available in the Google container registry that is free for everybody to access. And it has quite a list of extensive sets of tools on it. So I would say, if you're looking at this presentation and thinking, hey, I would just like to try this out, then if you go to the support site, you'll see the name for the public GCR image. And if we take a break at some point, I can also sort of drop it in the chat after. So don't worry, you don't have to build your own Docker to start. Just reuse the existing one that the program provides, and you can use that as sort of like your guinea pig to start with. I won't talk about the cost piece of this too much today because this is more high level intro. But if you do end up using this tool quite a bit, keep in mind that there's all kinds of cost saving hacks that exist. And the most important one for you to know is this thing called preemptible. So in this example here, there's the keyword preemptible for the runtime block, and there's a number next to it. And essentially what this is saying is that, hey, I'm going to run this task on the absolute lowest costing machine up to 3 times, because sometimes these machines die, sometimes they're intentionally ended early, so they have an inherent flakiness to them. But it's like a flaky machine that's also really cheap, possibly a fifth of the cost of the fully paid version of the machines. You can try running your task on a low cost VM a couple of times as a cost saving mechanism. And even what are the right numbers there, I'd be happy to talk about as well in terms of having a lot of lived experience using low cost machines. Any questions?
Hey, Ruchi, we did have one plugged into the chat from Chi. So if I call a task written in R scripts, does it mean I put, and then in parentheses, sbatch R script ... below the command line instead of doing quote hello world?
Yes, a good question. So let me see if I can find an example maybe towards the end to see if I can get you an R script example. And then what I might do is shift gears and show a different example that's not hello world, but not R script, but something in the middle. Yeah, because I have that prepared. Let me see if I can dig it up. No, it's not this. I might have to switch windows. Just give me 1 second to make sure I get it ready. Sorry, 1 second.
No worries. And if this is something that maybe might take a little more time, we can always follow up with them through the support desk and provide the example too.
Absolutely. Absolutely. I'm almost there. I would love to show people a real example that's not hello world, because it kind of means nothing to most of you, and I totally understand that. Okay, I'm going to go ahead, stop, and reshare a different screen where I have loaded with an example. All right. Okay, so what I'm doing is looking at an example tutorial workspace that exists. I found it. I'm new to the program. I've been using the support documentation to sort of see what exists, and I found it very helpful. So I was looking at one of the support articles that referenced an existing workflow that's been written using GATK validate variants. So I was looking at it to see if that would be useful for us to look at together. I think the answer is yes. Okay, so here is an example of more of a real life workflow. And let's look at a real life task. Yeah, so in this case, it's running the GTK tool called validate variants. So, and there's quite a bit of inputs that have to go into it. So this is how it's set up. And the main thing to keep in mind is that there's special syntax you have to use when you're piping in inputs into your command. So for example, the reference FASTA file is a variable. So that's why it has a special squiggly in syntax around it. And it's also specified as an input here. So whatever serves as the input kind of flows its way through to the command and executes this way. And this is all using a publicly available Docker image. This is also another example of a public Docker image. The Broad publishes some, and the AOU program also publishes, and I'm sure other orgs do too. I just don't know for sure. And so I'm thinking about the question about the R script. So I think the main thing is that you will want to likely pass in the R script file as an input. So that would be one of the parameters you'd specify up here. And then you would want to call the R script command as if you were running it from a terminal. And that should work as long as all the right stuff is packaged into the Docker image. I am curious for the person asking that question if they've tried this yet and have potentially run into issues that I might not be anticipating. Yeah, okay, great. Just curious. What I will do is pull out a real example and a real Docker image that pair together and that have provably worked. So it can be a good base. And maybe that's a good one to add to our tutorials as well, in case that's sort of a common need. All right. Okay. So I think the main thing to keep in mind is that in this example, the main thing to keep in mind actually is that if you're a first-time user, try to keep your tasks not too complex from a command standpoint. Each task is meant to be sort of like a composite. It is meant to be sort of a composite operation. And so the best way to write workflows is often have separate tasks rather than the same task does a series of 3 or 4 different commands at the same time. So try to pair together your tasks and your commands as the most simple command you can imagine as one task. And then when it's time to build out the workflow, you can string together lots of tasks. And I say that because the engine is designed to most effectively run different tasks together. And that's sort of built into the design of how the engine works. Any other use case, kind of like the R script one, where you're trying to think about how to put your analysis into this context and wondering if it's the right thing to do. All right. So what I'm going to do next is just give you a visual of how all of this actually works in the All of Us Research Workbench. Yeah. So I'm going to go ahead and log in, clear out some of the tabs I'm not using. So this is just a tutorial one. And now I'm going to start from a different space, my own Scratchpad. So I'm going to go ahead and open the workspace that I've been using most recently. If you use the Workbench quite a bit, then you may have noticed a new app symbol that's shown up on your right-hand panel. It looks like a little flying pig. That's intentional because this is literally the logo of Cromwell is a flying pig. There's like just a long and kind of funny story behind it that I'd be happy to talk through the end if anyone is interested. But anyways, just one thing to keep in mind is that the Cromwell solution is definitely still in its beta phase. We already know there's rough edges here, and we already know we have certain improvements we want to make. And so the beta flag is there because we would like to be able to sort of make big changes to it in order to fill the gaps. And so this is just something to keep in mind. But we're not really going to do any big breaking changes like blow away your data or anything like that. I think we are thinking about how to round out the experience and the UI for this. Okay, cool. So if you go, and this is another logo that I think might be new to some folks because now that there's multiple applications, the Cloud and Lightning logo will tell you, well, what are the different applications and which ones are running. The main thing to keep in mind is that you've noticed already for your Jupyter notebooks, you have the option to pause, run, and delete. And for Cromwell, you can either run or delete. There's no pause functionality right now. So the best way to use Cromwell is to get it started up and run your analyses. And this won't shut down while your workflows are actually running. And you should be able to come back to it, look it over. And once you have your analysis running, save those results before deleting the application. That is the most important thing. So what I'm going to do is come here and show you what this will look like for you if you don't have this set up. So let's say you're interested in starting and using this for the first time. So I'm going to go ahead and just see if I have another workspace where I could get this going. No, I think I would have to create one.
Ruchi, I don't know if it matters, but you might want to use the control to your workspace.
Yes.
Sometimes that matters for certain things. Sorry.
No, you're totally right. And plus, in this case, I actually don't need. Always better to use less access than you need. I'm definitely missing something though.
Let's choose yes or no, the last option.
Yeah, number 6.
Yeah, let's choose
If you create a new space, you have to fill everything, So it's like the best is just duplicate one of your workspace if you want. Otherwise, it will take time. Yeah.
That's a great point. I will duplicate my own workspace. So I wanted to just I've kept the applications warmed up so we're not waiting in order to in whatever time it's going to take for them to initialize. So, but I would like to walk you through some of the steps to actually turn on the applications.
Maybe this might be a good time for this question since we have a little bit of a pause, but some of the other people on the call may be wondering, how long can you step away before the Cromwell environment may end on you? So if you have something running, what is a good time to check back in to make sure it's still going and being successful?
That's an excellent question. I think it really comes down to the type of commands you're running in your tasks. So I know something like validate variance, it shouldn't take days. It should certainly take but it takes more than minutes. So I know it's less than hours. So it's something I would imagine starting at the start of my day, setting it off, and then towards the end of my day, coming back to it to see, hey, did it finish or are there any errors I want to debug? So depending on the type of workflow you've crafted, you'll want to, if you were running this on your own computer, it shouldn't be too much longer to be able to run it through this infrastructure, because there are some wait periods between copying files around, getting Docker images, getting everything set up behind the scenes. But that should add like maybe 10 minutes to what it would look like on your normal computer, but not more than that.
And then just to tag on to that, Gordon did have questions. So does the 24-hour auto pause and or the 7-day, 2-week auto deletion affect the Cromwell app?
It does not.
Okay.
I feel like it's probably going to be here. I feel like that question is probably going to be one of the more common ones that people will see as they start exploring it. So I think I'm making a mental note to add a tooltip to address that directly in the UI.
Great. Yeah.
I saw something in the chat. Okay. Has the auto deletion been changed from 7 to 14 days? I believe that is true, that it auto deletes after 14 days, but I'd want to double check just to make sure I'm not mixing anything up.
Yeah, I think it may still be, and this is for Jupyter notebooks and stuff, that inactivity after 7 days is auto deleted, or after 14 days of original creation, if that makes sense.
So I'm going to show very, very quickly how to start up the Cromwell environment. So you go ahead and you click into it. There are a couple of support articles built in here to this page that could be very useful depending on where you're at and what you're trying to learn. So there's some Cromwell documentation, workflow, and WDL documentation that could be helpful. So if you're trying to build your own WDL and example to start with, I would definitely start with article number 3. You have a sense for cost of this that's running. So you can loosely imagine, if you leave this running for a day, how much it would cost you. So it lets you do that math simply. And for now, we don't allow flexibility because we've pre-chosen defaults that should work for most people. So we're hoping this is actually net good, not having that customization, because then it can be sort of a mindless operation, and it should scale pretty well. Unless you're doing something wildly big, like working with all the genomics data available in AOU at the same time. In that case, we should chat, because you probably need a very different compute profile. And so once you hit start, you'll I'll be able to show you there's like a little icon where things are starting to work up. So there's a two-step process to getting the workflows loaded to be able to do the workflows. You have to turn on Cromwell, and then next you have to launch a Jupyter application, because that's the interface through which you'll connect into Cromwell. What does that actually mean? And I'll show you in a second. Okay, so I'm going to hop over to a place where I actually have Cromwell running already. And then what I'll do is I'll show you why would I also need Jupyter Notebook turned on in order to use Cromwell, and I'll explain in a second. So I have a test notebook that I have loaded, and I'm going to edit and get it running. Excellent. So I'm going to go ahead and I'm going to snip this. Nope, that's not what I meant to do. I'm going to go ahead and just cut it out. Okay. So you may or may not already be familiar with the concept of snippets, but if you're going to use Cromwell, you absolutely need the snippet, because that's the most important part of this. So once you have the Cromwell application running, the actual interface you need to interact with it could either be something like the Jupyter Notebook, or it could actually be the Jupyter terminal. So in order to now connect into the server, you have to run one Python snippet. So if you go under snippets, there is a Cromwell setup Python snippets, and you just kind of hit run. And essentially what this is doing is that it's connecting into this environment. And so this is an important one-time step that you have to do. So it's looking for Cromwell, checking for the right status, making sure things are in a good state. And this is a good thing. It found the Cromwell app, so everything is good, and the status of it is running. That's also good. So you're just kind of looking for general confirmation. And then when you're at this stage, what you want to do is use Crom shell. So Crom shell is a CLI for interacting with Cromwell. And it's a CLI where you can submit workflows, check status. So it just lets you do things a little more smoothly. So here, what you can do is there's an alpha version of this command line tool that I'll be using today to demo most things. So what I can do is I'm just double checking that, hey, is there a Crom shell alpha already available on this machine? And the answer is yes, it's ready to go. These are the commands I can leverage. So now I'm going to use this information to go ahead and run an example workflow for us. Now I'm switching over to the terminal because at least I'm more fluidly comfortable in this space to do everything. And I'll explain why in a second. Okay, so I'm going to go ahead and see if I can clear some of this for now. Okay. So I mentioned, okay, this is the command line tool that I'm going to be using. The main thing to keep in mind is that the primary steps you care about are things like submit. So you'll want to submit the workflow, check status of it, and check for logs of the workflow. So we'll look at those pieces together. Okay. Now, in order to do all this, what you actually need is a workflow and some inputs. So what I've done is I've created some example. I've used the Hello World WDL here, but I'd be happy to pick a different one as well in case anyone sees a WDL on the internet that they'd like to try out together. So what I'm going to do is just cat what's in here to help you see what I'm running. So this is just an echo command. What I'm trying to do is find the output. The output in my case is just going to be whatever is written to the standard out file and preserving that as a file. And in my case, I'm also using a very, very generic Docker image, just Ubuntu, just very commonplace. Okay. And then, so you'll notice that actually I have a command, I have an output, I have a runtime, but I don't have an inputs section here. And that's because not every task requires an input. So in this particular example, I'm using the most simplified case possible. And even though there are no inputs, I do have to specify an empty file. So I can do something like that with just an empty JSON file as my inputs. So I'm going to use this almost like a control example and run Crom shell and run it using Cromwell. So I'm going to go ahead, get my handy dandy command line tool. I'm going to hit submit. What I have to do is first give it the file path to my WDL. and then the file path to my inputs JSON, and then go. There's a lot of logging that will happen. So I would say for most of you, don't worry about reading these server level logs because it's only necessary for debugging, not for general viewing for you. So then what I'm going to do is take on this ID. And I see that the status right now is submitted. But because it's a very simple task, I expect it to finish very quickly. So I'm going to go ahead and check status again. Okay, so it succeeded because, well, it wasn't really doing much to begin with. So this is just more of a litmus test than anything else. And then you can increasingly make your whittles more complicated as you're doing some of this development. And so I like it. I like doing a lot of this in the command line and in the terminal, specifically because there's a lot of file editing that happens as if you're building your own workflow, then you're going to be doing a lot of file editing. And so it's nice to be here. I think once you have if you're reusing an existing whittle somewhere, then it matters less, all the file editing pieces. And so in that case, you may actually find that the Jupyter Notebook interface is more to your liking. So it's not that you cannot do this from notebooks, or that you can only do this from the terminal. That is not true. But depending on how much editing you need to do to build your workflow to get it up to par, you may find that the terminal is easier to work with.
Sorry, can I have a quick question, Ruchi?
Please.
Since we are demonstrating this case, can you show me how to show the output file if you have one?
How to look at the output file?
Yes.
Yes. Okay. No, great question. So we just ran a workflow, right? So what I should expect is I should expect some output file that should be stored. So let me see if now I'll show you where all the logs go, because the outputs have been generated, but not on this machine, right? So if I ls where I'm at right now, nothing that reflects like the output are here. So the thing is that all the outputs that get generated from this Cromwell live inside your workspace bucket. So this workspace has I can write gsutil, and there's an environment variable that's accessible to everyone. Okay, so now when I ls this, if you've run a workflow, even if it succeeded or failed, doesn't matter. You'll notice that there is a new directory here called Cromwell execution, and it's a little bit deep. The outputs are nested a little bit deep, so it's going to take a little bit of navigating, but I'll walk you through what I would do in this example. Yeah, so I know that this is my oh, that's not what I meant to do. I meant to ls. I wrote it wrong again. So next, what I'm seeing is that the name of my workflow is the next directory. It's going to go ahead. Oh, I lost my window. And in my case, I ran this workflow like 2 times earlier today just to sort of practice for myself. So that's why you're seeing multiple directories, not because I've run it that many times here. And then if I just pick any one of them, the next thing you'll see is that this is the task. And I'll explain what cache is in a second because it's slightly complicated and I chose not to mention it yet. And now what you're seeing is the actual outputs. So the standard out was the actual output that I stored in my task definition. By default, there's three or four different files that also just exist. So if the log file is more of a debugging tool. So if you're trying to figure out why something failed, this is going to be the .log file is going to be the most important one. The return code is also a debugging file. So in case of failures, they're very important. And the standard error also kind of the same thing, but the standard out file is the actual output I generated. And so if I look at this, this is the thing that should have confirmation that did my task run appropriately. So this is the thing that has the hello world in it.
Thank you
And
so much.
And I showed you like the really painful way to look at all of this on purpose, because I just wanted to explain that there's a directory structure here. I think you should be able to do something even simpler. No, okay. I was hoping that there was like a recursive structure that will give you everything, but I'll see if I can dig to find an easy way.
Maybe dash capital R.
Yes. The benefit and the challenge is that every single thing you run will show up here, and that's my challenge. Is like I've just ran a lot and cleaned up none of it. There's also other pieces of information that you can leverage from here. So if you run a workflow and it's been running for too long and you're wondering what's going on, you just kind of want to kill it, this could be a useful thing to do. Just you can hit abort on it. The other thing that's nice is that you saw me copying around the long UUID to check status. So you can also alias things so that you can kind of make it easy to come back to and look at them. The logs function is broken right now. This is a known error, so the team is fixing it. But instead of having to do the long GSUtil thing that I just did in the future, what we're hoping is you can just hit crom shell alpha logs and then the UUID, and then all those logs are just they're downloaded onto your machine for you to look at. So this is going to be the future of how to do it. I think and I think so. I imagine actually the hardest part of doing this is potentially going to be writing out your workflow in case this is new to you. And also, I wanted to show you a real inputs file, because so far the example I showed you, it was an empty inputs file. So this is the syntax of actually what needs to be your input file is important here. So it's a key value kind of setup here in your JSON. So on the left-hand side is what you have the name of the variable in your WDL. So for example, in this case, I have an input called VCF. It's part of a task called validate. Yeah. And so, and it's part of a workflow called validate VCF. Here's the name. Yeah. So when you're building the inputs, oh, I lost myself. It's the name of the workflow, the name of the task. In this case, since it only has one task, it's able to sort of infer that, and then the name of the actual variable that your task will need on the left-hand side. And then on the right-hand side these are the file paths. To the file paths, or depending on if they're parameters, they might be numbers, strings, letters, whatever it is. And there's very constrained types that you can put in, but generating this JSON file will be a really critical piece to pull together your workflow and your inputs before you can hit submit in most cases. The other thing that I haven't done live but could be useful is there's a tool called WOM tool, which is also referenced here. And essentially what it does is that it has a bunch of utility functions to do things like, hey, I wrote this workflow. Can you build me an empty inputs JSON file? So can you just tell me what are all the things that I need to provide inputs for? It can do things like that to make your life easier. So let me see. So let's say you ran a workflow. Maybe before you actually, let's say you built a workflow. Before you actually want to run the workflow, you may just want to validate it. So there's a function called validate on it that will just tell you, hey, these are the parts of your workflow that are not right. Or let's say you wrote your workflow, it's been validated, but now you're going to need to provide it inputs. So there's a function in inputs that prepares an empty version of this inputs file for you. And it has some really great, like, sort of highlighting functionality that just makes it easy to sort of build and debug. So this is WOM tool will be your best friend if you're writing a workflow from scratch. But in general, I would recommend do not write workflows from scratch, because what you will find is that it's possible that a lot of the tasks that you're trying to draft already publicly exist in some GitHub repo. So it's definitely worth checking online first, or even just checking in with the support team, because there's a lot of pre-built resources that exist, especially if you're working with genomics data. Those are pretty well encapsulated. It all comes down to the tools you're using. So there's nuance to what I'm saying for sure, but I'd be really surprised if you're working with sort of the common genomics tool if some of those tasks don't already exist and are pre-written for you. I'm just checking into the chat quickly to see if anything new needs to be addressed. Yeah, I see a desire to see a Cromwell example for running a GWAS in ARU. I feel like I think in terms of figuring out the right fit for your example, I think Hail might be actually an easier solution than even Cromwell for parallelizing the type of analysis you're interested in doing. I'm curious if you've already tried using it and found that it did or didn't work to some degree.
I tried, I'm just not as familiar with Hail. So I was able to run it with Plink, but then of course you need to spin up a very huge machine. So I was just wondering if this might be better. So I guess not. Thanks.
I can see, I do know people who have run GWASs in Cromwell. I just thought it was fewer commands running it in Hail. That's why I was saying that, but I'll dig up an example of what it would look like in Cromwell. So I feel like I have at least 2 items to make sure I can send out an example of running a workflow that's executing R scripts, and also the example for running a GWAS using Cromwell.
Great, thanks.
Let's see. I think I'm going to anticipate possibly the hardest part of this is going to be when something does fail. It very often is because there's not enough disk space or there's not enough CPU, and that can be hard to parse. So my biggest recommendation is that if you see your workflow fail for the first time, the place you want to start is by tweaking these variables. So you may want to double the memory you're using, or you may want to increase the CPU or disk, because very, very often in my lived experience, it's almost always has to do with not having enough resources at the runtime level. All right, I'll leave it at that last tip.
Great. Thank you so much, Ruchi. That was really awesome explanations and demonstrations. And we do have this recorded, so we'll be posting it early next week sometime. So anybody on the call, feel free to come and watch it again or share it to other colleagues. We do have about 8 minutes left in our call today. So does anybody else have any questions? At this time, they may not even specifically have to be for what we went over today. They could be general, all of us questions too as well. So I'll pause for that.
So I do have a question. Thank you, Ruchi, so much, for such great demo. So right now we have, with new V7, we have a new Cromwell system, like with the icon, the cloud environment activation, something like that. In the meantime, we also have a featured workspace, right? Which is was existing from V6. So my question for you is that, if we run featured workspace without touching the new icon stuff, will still that the featured workspace notebook will it work?
It will still work, yes. I think the only reason we haven't updated that old featured workspace is we're building out the new featured workspace that encapsulates these things we're talking about. So We just need to get the latest and greatest tutorial for Cromwell up as a tutorial workspace, and then we'll probably modify the old one to remove it. It's not that the old methodology won't work. It's just that it's literally more work for you. So we're trying to move people away from the old way of doing it and towards the new icons because it's less maintenance for most people.
Thank you so much. Yeah, that's all I need to know. Thank you.
Hi, Ruchi. Thanks so much for your demonstration. You just mentioned that for doing the genome, maybe the hair matrix can help you to do it like GWAS better or faster or do parent. So I just wonder for Cromwell, we have the scatter thing. I mean, the workflow scatter, does it look similar to parallel computing? And whether if we can code hair matrix script in Cromwell also?
You can call. It's complicated to run it Hail. If you're trying to run Hail and Cromwell together, it gets complicated. But I think you're saying, what about putting Hail matrix table as an input to Cromwell? Is that what you mean?
Yes.
I think you should be able to feed the Hail matrix table into Cromwell. The question is how to chop it up into small pieces before it can be scattered, before the tasks can scatter across them. So we may want to do something together to make sure that syntax is properly laid out for you to be able to run it that way. Because what I can share, maybe a third thing I can share is how we take a VCF file and break it up to do the scatter. How to now do that for a matrix table. I'm trying to visualize quickly, but let me see if I can send an example for that as well. Is like how to scatter across a matrix table.
Yeah, that's a great question. And if you do want to follow up on that too, please submit, as Sam just put, to support@researchallofus.org. And we'll continue the communication on a lot of these examples and stuff like that too.
Yes, thank you. Thanks. I follow up. Thanks.
I do see your hand raised, Hugh, if you wanted to come off mute.
Thank you. I have the impression that there is another office hour on May the 19th regarding the new data release, but it doesn't show up on the event calendar. So is it still in planning?
Yeah, I can answer that. It's going to be on June 9th, I believe, instead of May 19th. So we just moved it.
Also, the time is rescheduled to
June 9th. Rescheduled. Yeah. Exactly.
Okay, great. Yeah, thank you.
Do you have any other questions? We got about 3 minutes left. I do see that in the chat. Can you send out the Zoom link for June 9th? If it's not already on our calendar, we can probably get that updated, but we also send out the invites to all of our Zoom sessions, a few days in advance. So just be looking for that in your emails too as well. And I think Sam just shared it too. Incorrect. Yes, the time is going to be from 1 to 2 p.m. Central Time, not Eastern, Central Time. All right. If we don't have anything else, thank you everybody for joining. Thank you, Ruchi, so much for this demonstration. And I know we definitely are going to be leveraging this in the future too as well. So hope everybody has a great rest of their day and enjoys their weekend.